All right. Hello, Precalculus class. We're going to go ahead and continue to talk about permutations and combinations today. We're not going to learn anything new. We're just going to do more examples, and your homework tonight is going to be a worksheet with more examples of these kinds of counting problems. Okay, so all of them will be using either permutations or combinations, and you need to figure out which one it is and how to do it. All right, because some of them are a little bit more complicated than others, especially these card problems. So we're going to start off by working on some of these card problems at the bottom of the page. Yesterday in our online class, we did a couple of them. We did A and B. I'm going to continue working through some of these and show you how to do them. Okay. Excuse me. I'll probably take about 20 to 25 minutes to do some examples. We'll see how many I get through. I'm not going to finish all of them, but it doesn't matter. All right, I might skip around as well. So let's look at this one. How many 5-card hands have 4 aces and 1 other card? Okay. So, in order to figure this out, we are going to have to count it. And when we do these hand problems, actually, I'm going to back up and do the 2 examples that I already did today, or yesterday. It's today for me, but for you guys, it's yesterday. All right, I'm going to do those 2 examples. I'll do A and B first. All right, and let's make sure that we understand that a deck of cards has 52 cards in it. There are 4 different suits. The suits are the hearts, diamonds, clubs, and spades. All right. And every suit has 13 different cards. What are those cards? Well, there's a 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there's the jack, queen, king, and the ace. So that's 13, all right? That's how a deck of cards is made, all right? It's got 13 of each card, 4 different suits. So 4 times 13 is 52. So there's 52 total cards. All right. And yesterday we talked about how many different ways there are. In poker, you get 5 cards. How many different combinations of 5 cards are there? Well, that would just be we are going to choose 5 cards from 52, all right? So the way we do that is we just go, okay, I'm going to choose 5 cards from 52, all right? So it's the combination of 5 cards from 52, all right? Which, if you use the formula 52 factorial, and then 52 minus 5 is 47 factorial, and then 5 factorial. So remember, on combinations, the bottom 2 numbers are always going to add to equal the top number. Okay? And if you stick this into a calculator, which I did yesterday for you, the answer you're going to get is... what happened to my problems? I don't want to put it into a calculator right now. It's 2,598,598, and then 960. Okay? So that is the answer. All right, that's pretty easy. All right, you guys should already know how to do this type of combination. But here it's going to get a little bit more complicated. And the way we're going to do this is we're going to use the multiplication rule, and we're going to divide each of these things up into some steps that we're going to do. All right, so this question asks, how many 5-card hands of the same suit are possible? That means that all 5 cards in your hand are in the same suit. That means maybe I've got 5 diamonds or 5 hearts or something like that. All right. That would be all of the 5 cards are the same suit. All right. So we are going to ask, our question is, how many different ways can that happen? And what we're going to do is we're going to divide it into 2 steps. First, we're going to pick a suit. All right. And there are 4 different suits, and we're going to pick one suit. All right. So we're going to say, okay, well, 4, choose 1. All right. We're going to, out of 4 suits, we're going to pick 1 suit. Okay. And then we're going to say, all right, now that I have a suit, I'm going to pick 5 cards from the 13 cards in that suit. So we're going to do, out of 13 cards, we're going to choose 5. And that will give us 5 cards that are all in the same suit. Now, whenever we choose 1, so n comma 1, then the answer is always going to be n. All right? It's always going to be this number. So 4 choose 1 is actually just 4. All right? And then we're going to do 13 choose 5. Well, that's going to be 13 factorial divided by 13 minus 5 is 8 factorial. And 5 factorial. Okay? So then all we have to do is do 4 times 13 factorial divided by, and then put in parentheses, 8 factorial times 5 factorial. And then it equals, and you're going to get 5148. 5148. And that is all the different ways that you can have 5 card hands that have the same suit. Okay? Got it? All right, next. Now we're going to move on. How many 5 card hands have 4 aces? Okay. Well, first of all, let's say how many aces are in the deck? 4. And we need to pick all of them. All right? So the first thing we're going to do is we're going to say, all right, we have 4 aces, and we're going to choose 4 of them. So we have to choose all 4 aces. So it's going to be 4 choose 4. Then, after we have chosen all of the aces, we have 1 more card left. Well, how many cards are left in the deck? 52 minus 4, which is 48. And from those, we are going to pick 1. We only need 1 more card, right? So we're going to say, all right, well, there's 48 cards left, and we just need to pick 1 of them. All right, so how do we do this? Well, whenever we have a number and then we choose the same number, so n comma n, there's only one way to do that, right? There's only one way to get 4 aces if there are 4 aces in the deck. You have to get them all right? So that's going to be 1. And then remember, I just said that if you have a number and then we choose 1, well, that's just going to be the number. So it's going to be 48. So the answer is there are 48 ways to have, or 48 different 5-card hands that have 4 aces. All right. Now I want you to stop and think about that for a second. What does that mean? Does that make sense? Yeah, it makes sense. Think about it. I could have 4 aces and the King of Hearts. I could have 4 aces and the Queen of Hearts. I could have 4 aces and the Jack of Hearts. I have 4 aces and the 10 of Hearts. How many different ways can I have 4 aces? Well, I've just got to go through every other card in the deck that could possibly be there. And those are all the different hands I could possibly have with 4 aces in it, right? So how many are there going to be? There's going to be 48 because there's only 48 other cards that could be in that last spot, right? So that is what this means, okay? Now let's look at D. How many 5-card hands have 5 face cards? So we're going to choose 5 cards, but they have to be the face cards. What are face cards? The face cards are the cards that have a person's face on them. So the Jack, the Queen, and the King. There are 3 for each suit. So how many suits are there? There are 4 suits. The hearts, the diamonds, spades, and clubs. So 4 times 3 is 12. That means there are 12 face cards. And we need to choose 5 of them. So that's going to be very easy to calculate. It just means that, well, there are 12 face cards, and we have to choose 5 of them. That's it. All right, so it's going to be 12 choose 5, which is 12 factorial divided by 12 minus 5, which is 7 factorial, and then 5 factorial. Okay? So what is that going to equal? Well, now I'll pull up the calculator and we'll do this. All right, so we have 12 factorial divided by, and then use parentheses, 7 factorial times 5 factorial. Close the parentheses and hit equals. And you get 792. So there are 792 different ways to get a 5-card hand that has 5 face cards in it. Okay. Next. This one says, how many 5-card hands have 3 of a kind? 3 of a kind means the same number or face card. For example, 3. If I get a card with a 3 on it, it could be the 3 of hearts, 3 of diamonds, and 3 of clubs. That would be 3 of a kind, all right? Because I have all of the same kind of cards. It could be queens, queen of diamonds, queen of spades, and queen of hearts. That would be 3 of a kind, all right? And then the other 2 cards can be anything, all right? Sorry, excuse me. All right, so how are we going to do this? Well, the first thing we're going to do is we're going to pick which card are we going to try to get 3 of a kind of, all right? Well, how many different kinds of cards are there? 13, right? There's the ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, King, Jack, Queen, King. So 13, all right? So we're going to pick one of those kinds of cards. So we're going to say, of the 13 kinds of cards, we're going to choose one of them. All right? Now that we have picked a card, a kind of card, we are going to try and get 3 of the same kind. Now, how many of the same kind of card is there? Well, there's 4, right? Because there's a heart, a diamond, a spade, and a club. There's 4. So of the 4 of those, we have to pick 3 of them. All right? So that's going to be 4, choose 3. So this is going to give us 3 of a kind. All right? Now we need to pick 2 other cards. All right? So how are we going to do that? Well, we don't want to get that same card again, right? Because that would make us have 4 of a kind. So how many different kinds are left? Well, there are 12 kinds left, all right? And we are going to choose 2 of those different kinds of cards. All right, so 2 other cards. We're going to do 12, choose 2. And then finally, the last step is of these 2 cards, we are going to pick uh, we're going to pick, I'm sorry, of these two different kinds, we are going to pick two of them. And the way we're going to do that is we're going to choose, I'm trying to think real quick. Oh, so of the first kind of card that we pick, we have to choose one. And then of the second kind of card we pick, we need to choose one more. So there are 4 of each kind, right? So it's going to be like this. All right, so this is, if we figure all of this out, this is going to give us this, all right? So how do we do that? Well, 13 choose 1 is 13. Times 4 choose 3. Well, 4 choose 3 is, if you think about it, 4 choose 3 is the same as 4 choose 1, right? Because 4 choose 1 is this. And then 4 choose 3 is this. 4 factorial over 1, 3. But they're the same, right? This is 3 factorial times 1 factorial. This is 1 factorial times 3 factorial. They're the same. All right? So 4 and then comma 3 is the same as 4, 1. So we know it's going to be 4. All right? Then we need to do 12, 2. 12 choose 2. That's going to be 12 factorial divided by 12 minus 2 is 10 factorial, and then also 2 factorial, all right? And then 4 choose 1 is 4, and 4 choose 1 is 4, all right? So if we calculate this all out, we're going to get, let's see, we have 13 times 4 times 12 factorial times 4 times 4. And then we're going to divide that by, and put in parentheses, 10 factorial times 2 factorial. And then close the parentheses and hit equals. And we get 54,912. All right, 54,912. So that's the number of ways that we can have 5 card hands with 3 of a kind and then 2 other cards. All right, next. Last one here with the cards is how many 5 card hands have 2 aces and 3 kings? All right, so again, how many different ways are there to choose 2 aces? Well, how many aces are there? There's 4. So we have to, out of the 4 aces, we need to choose 2 of them. Good. And then, how many different ways are there to choose 3 kings? Well, there's only 4 kings. So out of the 4 kings, we need to choose 3 of them. All right? And that's it. That's all we have to do. We chose 2 aces, then we choose 3 kings, and we're done. So we're going to say this is going to be, first of all, 4 comma 3 is just 4, again, because that's the same as 4 comma 1. So that's 4. And then this one, 4 choose 2, is going to be 4 factorial over 2 factorial times 2 factorial. All right, and actually, we don't even need to do this, so it's going to be 4 times, and then 4 times 3, because if we cancel that out, it's going to get rid of the 2 and the 1. And then we have a 2 on the bottom here. All right. We have a 2 times 1, which is 2 factorial. And so this is going to cancel out and become 2. So it's going to be 2 times 4 times 3, which is 8 times 3, which is 24. There are only 24 ways that we can have 2 aces and 3 kings. Okay? That's how we do these card ones. Now, I'm going to only spend about 5 minutes more. Let's quickly look at some of these. These are all pretty easy. All right, we already know this. If we're doing permutations, it's going to be 6 factorial divided by 6 minus 3 is 3 factorial. All right, if we're doing combinations, it's going to be 6 factorial divided by 6 minus 2 is 4 factorial, and then 2 factorial. Okay? And then the last one here, n factorial divided by n minus 1. Well, n minus 1 is 1, right? Okay, and then the thing that's left over is n minus 1 factorial, all right? But if you can see here, like if this is 5 factorial and this is 5 minus 1, which is 4 factorial, it's going to everything's going to cancel out, and all you're going to be left with is just n, which is what I was just saying. For example, I can't talk. If we do combination of 4 comma 3, which is n and n minus 1, I said that's always going to equal 4, right? Because it always will equal the same thing. If this number is 1 less than this number, then this and this are going to be the same, all right? All right, let's do a couple more examples, and then I'll let you guys go. You are going to buy a new car. There are seven different colors to choose from, and 10 different types of optional equipment. You can choose only one color and can afford only 2 of the options. How many combinations are possible? All right, so we're going to pick one color. How many colors are there? There's 7, and we get to pick 1. So that's going to be 7, choose 1. And now we need to pick the optional equipment. Well, there's 10 different kinds of optional equipment, and we can choose 2. So this is going to be the answer. Remember, n comma 1 is always just going to be n. So it's going to be 7 times, and then this is going to be 10 factorial divided by 10 minus 2 is 8 factorial, and then 2 factorial. All right. And if I calculate that out, you're going to have 7 times 10 factorial, and then we're going to divide by parentheses 8 factorial times 2 factorial, close parentheses, hit equal, and you get 315. Boom. All right, and let's do one more. There are 6. Actually, we're gonna skip down to this one. An urn contains 15 red balls and 10 white balls. Okay, so we have an urn. It's kind of like a bottle or something like that. Inside there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 white balls. Red balls, and I'll use black for white. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of the white balls. All right. Then the question is, how many ways can we choose 5 balls if all 5 balls are red? All right. So if we are going to choose all 5 balls that are red, well, how many red balls are there? There's 15. So we want to pick 15. We want to pick 5 from that 15. So that's going to be 15, choose 5. And that's it. All right. And it'll be 15 factorial divided by 15 minus 5, which is 10 factorial. And then 5 factorial. All right. And if you calculate this out, I already calculated it out. It's 3003. Yes. 3003. Boom. Next, we want to pick 3 red balls and 2 white balls. Well, how do we do that? Well, that's just going to be, first we're going to pick 3 red ones. So that's going to be 15, choose 3, because there are 15 red balls. And now we just need to choose 10 white balls from the 2. 2 white balls from the 10. So that's going to be 10, choose 2. All right, and that's going to be it. So how do we do that? Well, it's going to be 15 factorial divided by 15 minus 3 is 12 factorial, and then 3 factorial. And then we're going to multiply that by 10 factorial divided by 10 minus 2 is 8 factorial and 2 factorial. All right, and I'm just going to put that into the calculator now. So I'll do the top first. So we have 15 times 10 factorial equals this huge number. And we're going to divide by, and I'm going to put in parentheses all of these things. So it's going to be 12 factorial times 3 factorial times 8 factorial times 2 factorial, and then close the parentheses and hit equal, and you get 20,475. 20,475. Okay, good. All right, now, finally, we want to find how many ways there are to get at least 4. So that means we want to know, what if we get 4 red balls? Or maybe we could get 5 red balls. Those are all the ways you can get at least 4. Because we're only picking 5 balls, so you can only get 4 red balls or 5 red balls. Now, in this case, we're going to have to use addition, all right? Because we're going to first go, all right, what's the probability of getting 4 red balls? Well, that's going to be, out of the 15 red balls, we're going to get 4, all right? Oh, comma. There should be a comma there. All right, 15, comma, 4. And we need to say, because there's one more ball left over, we also need to choose 1 white ball, right? So that'll be 10, choose 1. All right, we're gonna, out of the 10 white balls, we're gonna choose 1. So this is how many ways there are to get 4 red balls. And now we're going to add getting 5 red balls. All right, 15, choose 5. All right, and when we do this and we add it all together, that's going to give us not the probability, but the number of ways we can get at least 4 red balls. All right, so we could get 4 red and 1 white, or we could get 5 red. That's all the ways you could do it. So calculate that out. It's going to be 15 factorial divided by 15 minus 4 is 11 factorial, and times 4 factorial, and then times 10, choose 1. Well, that's just going to be 10. And then we're going to add 15 factorial over 10 factorial times 5 factorial. All right, which we actually already found up here. It's 3003. All right, so but we need to find this first part out first. So it's going to be 15 factorial I pressed divide. Oh yeah, divide by and we'll put parentheses 11 factorial times 4 factorial. Close the parentheses and hit equals. Okay, that's this part. And then we need to multiply by 10 times 10 equals. So that's this whole part here. And then we need to add this. Well, remember, this is 3003 plus 3003. All right, and when you do that, you get 16653. All right, 16653. Yeah, that's right. 16653. And that's the answer. All right. Sorry, I went overtime again. I'm very good at going overtime. All right, so those are some examples. I'm not going to show you any more now, but your homework tonight is from these problems right here. You have a worksheet there, so it's not in your homework book, so just get a piece of blank paper or something and write them all down. All right, but yeah, these are all problems similar to what we just did. number 1, 2, 3, 4, you don't need to find the answer. All you need to do is say, is it permutation or combination? But then number 5 through 14, you need to say, is it permutation, combination, and you need to find the number of possibilities. Okay? Thank you guys. If you have any questions, please let me know. I'm always here during the school day.